Are we going to start with the preparation?
Yeah,
You want me to read the first one?
go ahead.
What notion is used to denote the probability of an event occurring?
You need to put symbol, right?
What's that?
I wrote in the chat the answer. Need to write this, right? This is the answer.
Just a moment.
If you want, I can read the second one. All agree with the first?
Yeah.
Okay. So second, please state and describe the three rules of probability. I could say the first one, and then the others could say other.
I'm going to pick up my notes.
Okay. Rule one is the probability of an event X is a number between 0 and 1.
So this,
One of the rules.
so
Who wants to say the second one? I can say the others.
I think the second one is the summary of summary is equal to 1.
Yeah.
Yes, yes. Okay, and the third one, who wants to say?
I'm loading mine so that I can read as well.
Okay.
So I just got here on mine is additivity. Oh, I wrote.
So the third question is, what does it mean to be random?
Yes.
Yes.
Without a conscious decision.
Um, aleatory. How you say it, aleatory? Aleatory?
Sorry, Maria, I don't understand what you said.
I'm going to put in chat.
Okay.
Aleatory.
Yeah. But what is? It's your definition?
Yes.
Okay. Mm-hmm. So who wants to read the number 4?
I can do it. What does the phrase discrete random variable mean?
Mm-hmm. For what I read, saying that is a random variable which takes only finitely or countably infinitely many different values.
So I think a discrete random variable, it has a pattern.
As a what?
It like follows a pattern. So like rolling
Okay.
a dice is a discrete random variable.
I have a definition as a random variable is a variable that takes on one of multiple different values, each occurring with some probability. When there are a finite or countable number of such values, the random variable is discrete. Random variables contrast with regular variables, which have a fixed, although often unknown value.
Yeah.
So number 5, we need to do in the group preparation. I don't know if all of you saw the videos of the lesson. The videos explain exactly what we should do in those questions.
Okay.
I don't know if I can put an image on the chat. I don't know. I will try.
Are we on question number 5 right now?
Number 5. We need to do it.
An 8-sided die has 8 possible outcomes for each
Yes.
roll.
Mm-hmm.
Calculate the probability of rolling a number greater than 5.
Mm-hmm.
So I got 0.37.
Yeah, I got 0.375.
Yeah.
Mm-hmm.
So the number 6 kind of goes along with it. It says calculate the probability of not getting a number greater than 5. So it's the opposite. It's 0.625.
Yep.
It's difference. 1 minus 0.375.
Yeah, you just do 1 minus 375.
Mhm.
Okay. Are we ready for the quiz?
Yes.
Let's start. Let me open the dialog on the quiz. Okay.
So when you guys are ready, I'll read number 3.
Who's going to share?
I'm there. I just don't know how to share it on the Google Hangout.
Okay. In the top left, you have a green button with the arrow. Can you click there?
You see this the symbol of the chat, and after that you have the
In the
green
top left,
of your screen.
you have a column with items, the green item.
Is it on?
Yeah.
Yeah.
Okay. So
Okay. And then it's not the first one, it's the second. It's window of application, or I have in Portuguese. The first one says it's my old screen, and second one is the window, application window or something like that. You click on that. That's all.
Roberto is sharing right now.
All right.
you can see it?
Yeah.
Yes.
Okay. So we're on question 3, right? Because 1 and 2 is just that we had the group meeting. Okay, I can read question 3 then. It says human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States will each of these blood types is summarized in the following table. So O blood type is 0.45, A 0.40, B 0.11, AB 0.04. The blood types of the portions given in the table above define a probability distribution.
So true, that one's pretty easy.
Yeah, I thought it was true as well. Does anyone disagree?
Yes, it's true.
Okay, number 4.
I'll read it.
Fine.
What is the probability that a randomly selected person in the United States has type O blood? Round to the 2 decimal places. 0.45.
Close.
I have 0.45 as well.
All right, moving on, I guess.
Okay. Number 5.
What is the probability that a randomly selected person will not have type O blood?
So that's just the opposite of O blood type, right? So it's 0.55.
Okay.
Yep.
So you do 1, subtract the 0.45.
Yeah. Yeah.
Okay. Use the following information to answer the next 2 questions. Caroline Willis and her colleagues conduct a study in which dogs are trained to detect bladder cancer. The dogs were trained to lie down next to a specimen
I think so.
derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. Seven bowels contain urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to the nearest 3 decimals.
So there's 7 patients, 1 person with cancer, so that would be 0.143.
Yeah, that's what I got as well.
Is everyone good with that?
Yes.
Okay.
Okay, question 7.
In a combined total of 54 trials, the dogs correctly identified specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chances alone. Which of the following statement is most appropriate? This provides strong evidence that the dog can detect bladder cancer. This is little evidence that dogs can detect bladder cancer. So it's obviously strong evidence.
No, no.
So it's strong evidence because it's a lot more than the probability.
Yeah.
True.
Okay. Number 8.
red.
I can read. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in polytable. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
0.13.
Yeah, I agree.
Could you explain, please? I don't understand why.
I didn't answer this one. I did not answer this one.
So it says if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? If you look at the
Okay,
table above, it has it.
0.13.
Yeah, 0.13.
Okay. I always put the 0 point and the others numbers. It's not necessary.
What? The 0 in front?
Yeah.
No,
I don't
No?
know if that's necessary or not.
I don't think
Okay.
It doesn't say. It just says round to the nearest decimal, 2 decimal
Okay.
spaces.
Mm-hmm.
Okay, number 9.
What is the probability that a randomly selected candy is green? Round to the 2 decimal places. So we must sum everything and put
Divide
minus equal.
Yeah, I think by adding all the other colors
Yeah.
and then subtracting that from 1, we would get our green.
The point 16.
What is the total?
0.0.
Yeah, so 0.84, and then one subtracted by 0.84 gives us 0.16.
Yeah.
16.
That's what I got.
Yeah.
And the next question,
0.16.
what is the probability that a randomly selected candy is not green? Round to 2 decimals.
Not green.
0.84. 0.
Right, so it's what we had to get the
Yeah, the
16.
total.
0.84, is that what you guys said?
Yeah.
So the next question.
The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from Cape.com. The following summary statistics were calculated. Could you scroll a little bit to
Up or down?
Okay. And the question?
To 24, it's the medium. Is that correct?
0.4.
That's what I thought it was. Because it's median is what's half.
Yes. I think it's 24.
Okay.
So
Okay, number 12.
Based on the
Top
information
25.
above, the top 25% of the students scored above what number?
I think it's the first quartile. I think it's 22. but I'm not sure.
It'd be quartile 3 though, right? 27?
I do think so. Because he says 25% of students are.
But it's the top 25. So I think it is quartile 3.
The,
You'd be,
yes,
I think,
yes,
I mean,
yes,
you-
right.
You're
Yes.
right with the 25%, but I think it's the third because it's the top 25.
Yes, yes, 27.
Okay.
Okay.
Number 13.
Which of the following statements is not one of the three rules of probability? If the probability is higher, then the probability is positive. If the probability is low, then the probability is negative. That's not correct. Because the probability is between 0 and 1, never negative.
Right. I agree.
Yep. That's it.
So I'm going to stop recording.
Okay.